you know that in order to subtract those two fractions, we need a common denominator. So the very first thing we did was move the 2 over. Now we're going to make these two denominators match. So this one's x minus 4. We're going to make this one x minus 4. So we just put an x minus 4 in the bottom, but that means we also have to put an x minus 4 on the top. Now at this point, I want you to write one fraction because you have set it up so that the denominators are the same. So we're going to have one fraction and the denominator is going to be what it is, x minus 4. So one fraction, one denominator, x minus 4. All right? Now, what about the numerator? Well, be careful here. We have x plus 5. Be really careful. This is a distribute. So it's minus 2x plus 8. Minus 2x plus 8. It's real easy math. You just have to be careful. All right, so now what have I got? On the bottom it's x minus 4. On the top it is negative x plus 13. Is that right? Now at this point, you're going to go to your number line and you're going to put 2 dots on the number line. I know that the dot for the denominator will be at 4. I can see that. This one is a little more confusing. So this happens a lot. If you're a little confused about where to put the dot, just set that equal to 0 and solve it. Just solve it like a regular equation. So that gives me negative x equals negative 13, so x equals 13. So the dot for the numerator is going to go at 13, and the dot for the denominator is going to go at 4. Once you have made one fraction and cleaned it all up, then you have a dot for the top and the dot for the bottom. That's it. Now, should those dots be colored in?
Only the 13.
Oh, beautiful. Only the 13. Because dots that come from the denominator are never colored in, no matter what. If it's a dot from the denominator, it is open. So because of the or equal to, I'm going to go ahead and color that one in, but not that one. The only thing left to do is shade. So what do I do? How do I figure out where to shade?
Guess a number.
Pick any number I want. So any number except for 13. I like to pick 0, guys. You are allowed to choose whatever you want, but 0 is so easy. If I put a 0 in, don't I just have 13 over negative 4? Is 13 over negative 4 bigger than 0? Is 13 over negative?
Yeah.
13 over negative 4 is not bigger than 0, right? So 0, which was right here on my number line, 0 would be over here, did not work. So I do not shade there. The number I'm guessing is 0. 0 is here and it didn't work. So that means I don't shade there, but I do shade here and I don't shade here. So the answer to the problem is just this little section. So I'll have a parentheses and a 4 and a 13 and a bracket. Why do I not have any infinities this time? A lot of the time I have infinities. Why do I not?
Because it doesn't go to the left or the right side of the number line.
That's right. The only time you're going to have infinities in your answer is when you have shaded the arrows, right? And I didn't shade the arrow part, I only shaded the in-between part. So there's my answer. Does anybody have a question about that? All right, then there's one more question on the quiz. There's only 2 problems on the quiz. One's going to look like this, and then the other one is going to look like this. Oops, oops, oops. I put the wrong sign in there, sorry. All right, so everybody's looking at this problem, I hope, and saying, oh, this looks different. I don't do all the steps I did last time. What do I do with this one? It's pretty straightforward.
Factor.
Yep, I'm going to factor it. And I'm going to take the extra second necessary to make sure my factors are correct. Because if you factor wrong, gang, you will get the wrong answer. So take a second and check your factoring. How do you think this one factors?
-5 and -3.
-5, -3. I think that's perfect, but I'm going to double check. So I'm going to FOIL it out. And I'm going to make sure that when I did first, outside, inside, last, I end up with my problem. Does this equal my problem? Yes. So that means I have factored correctly. I'm going to go straight to my number line. Where are my dots going to go on my number line?
5 and 3.
5 and 3, and I'm going to be very careful to put them on in the right order. This is a number line, so you've got to put the dots on the way they come when you count. Open or close dots?
Open.
Absolutely. Open. There's no or equal to there. And now I'm right back to where I was a minute ago. I need to shade. So I'm going to pick a number, and again, you can pick any number you want that isn't 3 or 5. I'm just going to pick 0 because it's so easy. 0's over here. That gives me -5 times -3. These are multiplied. So -5 times -3. That's 15. Is 15 less than 0? Nope.
No.
I see some heads shaking. That means I don't shade there. It didn't work. It gave me wrong information. So if I don't shade there, then I do shade here. And I don't shade there. This time my answer is just from 3 to 5. All right, is everybody clear about the 2 kinds of problems on tomorrow's or on Monday's quiz? Okay, so you can always, I did, like I said, put these problems in Schoology. So sometime over the weekend, you could go back in and try to do them again. Also remember that today at 2 o'clock, promptly at 2, you can come back on the Zoom and we can practice more of either or both kinds if you wish. All right, now let's get our note packet out. We are almost done with our notes. But, excuse me, but we need to spend some time with these word problems. some of which we've already done, actually. Some of it's review. But I'm back in my notes on page 23. We finished up there yesterday, or whatever day that was, and now we are ready for the word problems down here at the bottom. How much 12% orange juice needs to be added to 5 gallons of 15% orange juice to get a 14% solution? Oh my gosh, this is a blast from your past. Who remembers the setup for this? Oh, someone needs to remember. Oh my Lord. No one remembers?
Isn't it like a parenthesis plus 2 parentheses equals 2 parentheses?
Yeah, you got the structure of it. So when we did these, they look like this. But what goes in the parentheses? Yes, that is exactly the way we set these up. These were the two that were being mixed together, and this was the final answer.
Was it what it percent times amount?
It was. That's exactly what it was. So we took the amount times the percent plus the amount times the percent, and it equals the amount times the percent. If that doesn't look familiar to you, you slept through too many classes, folks. We did a whole bunch of these. All right? Now, let's read the problem and plug in what we know. It says we got some 12%, that's 0.12. And we're adding it to 5 gallons of 15%. And we're ending up with a 14%. So as you recall, every time we did one of these before, we ended up filling in 4 of the parentheses, and then the other 2 were empty. And we had to figure out what went in the other 2. Who remembers what goes right here?
Was it an
X?
It was X. Very good. You're redeeming yourselves. Good work. Now, remember, you are adding these 2 together to get this last one. So if you add X and 5, this is just going to be 5 plus X or X plus 5. Now, you'll need a calculator probably to help you with the arithmetic. And I do want to remind you, wait, that's not right. I do want to remind you that when you subtract the 0.12x, again, if you're using your calculator, it's not going to be an issue. But 0.14 minus 0.12 is 0.02. So I did it without a calculator. I could have made a mistake. Anybody doing it with a calculator and get the same answer, or do I have a mistake?
I got the same answer.
Yay, thank you. Good deal. And remember, when we do our word problems, we always put a unit on the answer. So this is, we're mixing gallons of juice, so we need 2.5 gallons of juice. All right, let's try the next one. Do you see that the setup will be exactly the same for this next problem? So let's see if we can fill our stuff in. Why don't you try to fill in as much as you can before I start filling it in? Somebody's audio's on, which is fine, except we hear a bunch of other noise. Okay? So does anybody have anything filled in yet? This is problem number 2. What do you think? Will, you're always good for an answer. What have you got, William?
Yeah. So this is the thing where you.
Will, are you looking at your note sheet?
Yeah.
Okay, you're looking at problem number 2. All right. Tell me about the percentages. I can at least fill those in. What goes in this first percentage parentheses?
I don't know.
Well, are you reading problem number 2?
Yes, I just don't know which one goes in there.
Okay, well, what is the, read me the first couple words of the sentence. If what? William, if can somebody help Will out? I don't think he has the notes with him.
Yeah, it's if 8 cups of 54%.
All right, so let's stop
acid
right there.
solution.
Thank you, Gabe. Wait a second. If 8 cups of 54% solution, the amount is 8 cups and the percentage is 54%. All right, continue reading, Gabe. Next few words.
With some 84% solution.
Okay, we stop right there. With some 84% solution.
And this one we're gonna pick up?
Did you finally go find your notes?
I've had them right here.
All right, William. Thank you, Gabe, for bailing him out. All right, then what, William?
60% solution results.
Yep, so I got 60% here on the end.
Yeah.
Now, I got an empty parentheses here. That represents the amount of the final solution. So stop and think about what you are mixing together. You have 8 gallons and X gallons that you are adding together. So what's going to go here?
84. Oh, shoot. No, I don't know.
All right, just listen to me. I'll say it one more time. If I have X gallons and 8 gallons and I add them together,
It is.
not 8 times X, 8 plus X, right? If I add them together, okay?
Yep.
Now, William, I want you to look at this parentheses and I want you to look at the one from the last problem. In that parentheses goes the total. Total means you add. Okay, we've been through this, buddy. Millions of times. All right, here we go. So now I'm going to take 0.54 times 8. And I'm going to take 8 times 0.6. Because this is a distribute down here. And I'll move some things around, solving my equation. I did that right. I think I got 2. And my unit is not gallons, it's actually cups. Ari, did you get that same answer?
Yes, ma'am.
Thank you. All right, now let's read number 3. Number 3 is a different kind of problem. Does anybody remember the setup for problem number 3? It is not one of these. It is not amounts and percents. I'm not mixing anything. Does anybody remember? Our little formula, just like we have amount times percent, amount times percent. No, that's a good idea. No, to do a problem like number 3, we have to take 1 over the first person alone and plus 1 over the second person alone to get 1 over together. I thought we'd done some of those. Have we not? Is this the first time we've talked about that? Okay. Then you need to make sure you make a little notation. We'll do a couple. We'll get plenty of practice. Make a little notation. This is your general formula. Just like this is your general form for your mixtures, this is the general form for these problems where you have 2 people doing a job. Okay? So this means the first guy's time alone, and this is the second guy's time alone, and this is their time together. So it's a real easy formula. So here we go. Danielle can do her math homework in 4 hours. So her time alone is 4 hours. So we put 1 over 4. It's always 1 over. So whatever the time is alone, 1 over it. If Zach helps her, it will take them 3 hours. Now where does the 3 go? Is the 3 Zach's time alone, or is the 3 their time together?
Time together.
Exactly. So we're going to put 1 over 3 here. How long does it take Zach alone? So isn't that my X? Isn't Zach's alone time my X?
Yes.
All right. Is everybody clear with the setup now? It's real easy. They always look like this. All right. Now we got to solve it. So how would you suggest we solve this equation? I'll give you a hint. You're going to multiply by something. What do you think we might multiply by? Oh, that's an interesting idea. No, we're not going to do that, but that is an interesting thought. That might be kind of fun to do that, but that's not the easiest way. We're going to multiply by our common denominator. What is the common denominator for 4 and X and 3?
Is it 12?
It's actually 12X. Yep, it's 12X. We want to multiply by 4 times X times 3, so 12X. Please don't mess this up, you guys. It's really easy. What's 12X divided by 4? What does that become?
3x.
Yep,
3x.
3X. What's 12X divided by X?
Is it 12?
It is 12. Heck yeah, the X's cancel. And what's 12X divided by 3?
4x.
So now we have this equation, which you can subtract 3x from both sides. How long does it take Zach alone? Takes him 12 hours. Okay, number 4. Grant can paint the football field in 8 hours. Matt can do it in 6. How long will it take them to do it together? Does everybody understand that problem's going to have this setup? You got 2 people doing a job. This is the setup we use when we have 2 people doing a job. So who feels like you can write the equation for me for Grant and Matt?
Got you, Miss Ford.
All right. I'm ready.
So it would just be 1/8 plus 1/6 equals 1/x.
Yep, that's it exactly. You've got it. These are so easy. 1 over Matt's time alone plus 1 over Grant's time alone equals 1 over their time together. And this time, that's x. How long will it take them together? Okay. Nate, what am I going to multiply by? There's more than one answer, so don't worry. What do you think might work?
6.
Now, 6 is a good place to start, but will 6 cancel out an 8?
No.
Nope. So it's
What about 2?
will 2 cancel out an 8? In other words, if I put a 2 here, will that 8 be canceled out?
Wouldn't that make it a 4?
Okay, but I don't want a denominator. I want the denominator gone. So yes, it would change the denominator, but I want to get that denominator totally gone. So what will cancel out an 8 totally?
24.
Oh, 24. And not just 24, but 24x. Because you not only have to cancel out an 8 and a 6, but you have to cancel out an x. Now, over here, we did 4 times x times 3, and that's why we multiplied by 12x. You can always do that, gang. So you guys chose to multiply by 24x, which is awesome, but you could have multiplied by 48x. That would work also. You can multiply by whatever you want, but these have to cancel. So what's 24x over 8? What does that become? The 8 is going to be completely gone. There's 3x. There's no more fraction. 24 over 8 is 3. What happens here? 24 over 6. 24x over 6. 24 divided by 6. Yeah. And the x's cancel and leave me with 24. So 7x equals 24, and x equals 24/7 hours. It's okay to get a fraction. Sometimes that happens. It's okay. That's a little over 3 hours. 24/7. It's a little more than 3. So if they work together, they can get the job done in a little more than 3 hours. All right, let's go down to the bottom of the page there. Handwritten, it says Amelia can paint a room in 4 hours. With Aaron's help, it takes 1 hour. How long does it take Aaron alone? All right, somebody set that up for me. This is number 3, the Amelia and Aaron problem. Can someone set that up for me?
Is it 1/4 plus 1/? 1 over X equals 1 over 1.
What do the rest of you think? Is she right? Yep, very good. I see some nods. Good work. She's exactly right. This is 1 over the first person alone, 1 over the second person alone, and 1 over them together. All right, let's see if we can figure this out. What are we going to multiply by this time?
4X.
4x. Beautiful. 4 over 4, that's going to disappear and leave me with just x. The x's are going to disappear and leave me with 4. And nothing really cancels here, so I have 4x. So 4 equals 3x, and x equals 4/3 hours. So how long does it take Erin alone? It takes her 4/3 hours, 1 1/3 hours.
Miss Ford, why wouldn't it be 3 4?
Dividing by 3? Trying to get x by itself? That's a common mistake. You might want to force yourself to actually show the work, and then you'll see it. All right, while we're here, let's go ahead and do number 4, which is the mixture problem. So, kids, there's only 2 kinds of word problems here. There's these ones where you got 2 people doing a job, and then you have these ones where we're mixing things together. So you got to be able to tell the difference, and then you got to remember that if we are mixing things together, our format is all those parentheses, like I think it was Gabe said earlier. You got parentheses times parentheses, parentheses.
Wait, what problem is that?
This is now
The one on
number
the right.
over here.
Yeah.
That was the Amelia and Aaron problem. Number 3 down at the bottom, handwritten.
Okay.
And then I'm getting ready to do number 4 down at the bottom, which is another mixture problem. All right, so William, this was a disaster last time, but this time it's going to be better. Okay, William? Start plugging them in. What do you think? We're doing the very last problem on the back of page 23, down at the very bottom. So tell me what you think goes in these parentheses.
Yeah, so we're doing number 4, right?
Yep.
So, how much? 60%?
Uh-huh. So what do you want me to write?
The 16 right in the second one.
Yep, you're exactly right. It's 0.16. Yep, 16%. Very good. Okay.
So this is to be mixed with, what did I say, quart? Did I say quart?
It says 9 quarts. Yep.
Oh, that looks like an A. Yeah, so 9.
9 goes here.
Yeah.
And what goes here?
0.02.
Very good. Even got the decimal right. Good job. 0.02. 2%.
To get a 10% solution, so the 10 goes right there.
Exactly. So now we filled in everything that we could. So now we're kind of on our own. We have to figure out what goes in the rest of them. So what do you think is going to go right here?
Hold up. Isn't it like something plus X?
Not here. This is literally how much 16%. So that's just X.
Yeah.
I don't know what it is. It's some. Now, what's going to go over here in the total mixture?
What, 9?
9 plus X.
Plus it.
Yes. This is the added together. Look. X plus 9. That's what goes here.
Yeah.
Okay, so then we can work it out. And everybody should be working it out. Please not just copying down mine. Oh, no. Yeah, don't copy mine now because I just made a mistake. All right, anybody match 12? I got 12 quarts. Is there a nod somewhere?
Yeah, I got 12
Sam,
quarts.
good. Okay, good. Thank you. All right, so now what I'd like you to do is go to the very next page, the last page of your notes. And it is a bunch of word problems, 7 to be exact. So I'm just going to pick one, and you're all going to do it, and then we're going to come to a consensus about the answer. All right, so I'm just randomly going to pick one. How about number 4? Let's do problem number 4. Everybody do it right there on the paper. See if you can get it set up and solved. And then we're going to compare answers.
Wait, the one that starts with like Matt?
Yes, Matt can clean his room and Tristan is helping him. That's the
All right.
problem. Yep. Courtney, you got an equation for me?
I'm sorry?
Do you have an equation for me?
You mean to make up an equation?
Yes. For this problem number 4, have you written an equation?
No, I'm still working on that.
All right, let's make sure we're staying good and focused, okay? Caden Cole, you got an equation? I'm not saying the final answer. I'm just saying, do you have the thing set up?
Yeah.
All right, what do you have for number 4?
1 over 5 plus 1 over x equals 1 over 3.
Vincent, birthday boy, what do you think? Is Caden right?
Yes.
Yes, he is, because our formula, Courtney, is 1 over the first guy alone plus 1 over the second guy alone equals 1 over them together. There's 3 fractions here. 2 of the fractions you always know. The other one is x. In this case, what we don't know is the second guy, Tristan, his time alone. Okay, perfect. Chase Johnson, what are you multiplying by, Chase?
15?
Oh, that's a good start. What else? You need 15 and...
X.
Yes, so we're going to multiply
15x.
by 15x. Yep. We always got to include that x because we need that x to cancel out. So that would just be 15 there in the middle. Now, 15 over 5 is
3x.
3x. Yep, that's exactly right. Go with it. 3x. That's perfect. And then 15 over 3 is
5x.
yep, beautiful. So I'll subtract 3x and divide by 2. So it's going to take Tristan 15 halves or 7.5 hours to do the job by himself. All right, one more, number 5. Right now, here we go, number 5. Everybody do it. Let's see if we can all get this one right. Number 5. Courtney, I'm coming to you for the setup. Make sure you can do it. Problem number 5. We got Dylan and DeAndre baking a cake. Tell me when you got an equation, Courtney. Courtney, just the equation. What do you have for me? Oh, guys. Essence, you got an equation?
No, I'm writing it down on Notability. I don't have to think on it.
Okay.
I pay attention, Miss Ford, I tell you.
All right, William, do you have an equation?
No, Miss Ford, I think the last 2 questions, I think someone else should do it.
Oh, okay.
This 4, is it 1 over 2 plus 1 over x equals 1/3?
So 1 over 2 plus 1 over x equals 1 over 3?
That's what I put.
Okay, now let's talk about that for a minute. You've got all the right numbers. But what is our formula? 1 over, who's the first guy? Dylan. So 1 over Dylan alone. That's correct. This should be 1 over DeAndre alone. So this should be 1 over 3.
Oh, yeah.
Because
And
that's
the last one
DeAndre
was
alone.
x.
Yeah, and this is what I don't know. This is how long it takes them together. So remember, these two are 1 over each one alone. And then this is their 1 over together. All right, what would I multiply by in this case? Not 2x. Be careful. I need 2 and x. That's right, but I also need a 3.
6x.
So 6x. Yep, I'm going to
Yes, sir,
multiply.
Hector.
I'm going to multiply by 6x. So then 6 over 2 is 3x. 6 over 3 is 2x. And the x's cancel and leave me with 6. So 5x equals 6 and x equals 6/5 hours. You often get fractions, don't panic about it. The unit is hours, because that's how long they're baking their cakes. Okay, now next time I see you, which is Monday, you are going to have the answer sheet printed or copied, somehow copied, and you are going to have your homework ready to turn in. You can turn that in earlier if you wish. And we're going to be moving on, after we take our quiz, we'll be moving on into the next unit. So I have put the notes for chapter 3 in Schoology, the note packet. You absolutely, listen to me, gotta have it printed, okay? Essence and everybody else, you gotta have it printed. If it's not possible for you to print the note packet, then you need to email me. I will print one for you and you will come and pick it up. Or you can go to a friend's house and print it. But we absolutely have to have our notes copied, guys. It's a whole packet like we've been working in. We gotta have it copied. Okay? So email me if you need me to make a copy, and I'll happily do it and leave it in the front office for you.
Thank you, Miss Ford.
Have a great day.
Thank you.
See ya.
Thank you.
Bye. You're welcome. Courtney, you need to come back on, dear. I don't know where you were. This isn't the way to be successful.